Welcome to the circular function series. Circular functions cover all the basic functions of trigonometry, starting from right-angled triangle to angles of any size using a unicircle. Trigonometry and its functions have an enormous number of uses in our daily life. For instance, it is used to measure the distance between landmarks, the distance of nearby stars, and is also used satellite navigation system. Circular cylinders are used to print newspapers. Engineers exploit circles' symmetrical properties in making watches, clocks, air conditioners, and all kinds of vehicles. Every student should master trigonometry as one of the most important branches of mathematics. Great trigonometry skills allow students to work out the complex angles and dimensions in relatively little time. In this series, we will explore the properties of circular functions and how to use them to solve circular function-related problems through worked examples. Welcome to the first session of this circular function series. In this session, we are going to briefly introduce the basic concepts of circular functions, their properties and curves, as well as various trigonometry identity relations, symmetrical properties, compound angle formula. We will demonstrate 6 worked examples.
Hello, Math Champions! I'm Dr. Chen. If you want to improve your math skills and understanding so that you gain confidence, enjoy math more, and get better results, click subscribe and hit the notification button so that you don't miss anything.
Welcome to the series of circular function, and this is the first session of this series. As we know, trigonometry is the branch of mathematics that deals with angles and the relationships between angles and sides of a triangle. The trigonometry functions can be defined on the basis of a right-angled triangle or a unicircle. The unicircle is a circle with radius of 1 unit and centered at the origin, as it can be seen in the diagram. The coordinate of any point P on the unicircle is defined in terms of the trigonometry functions. Here, cosine theta is defined as x-coordinate of the point P. Sine theta equals the y-coordinate, where theta is the angle measured as a positive angle anti-clockwise from positive direction of the x-axis. It also can be seen that the relation of sine and cosine functions are complementary, since sine pi over 2 minus theta equals cosine theta, and cosine pi over 2 minus theta equals sine theta. As we know, with the unicircle, the x and y coordinates satisfies the equation of x squared plus y squared equals 1. The vertical distance from S to T is defined as tangent theta. As the triangle ORP and triangle OST are similar, y divided by x equals tangent theta. There are 3 other circular functions: cotangent theta, secant theta, and cosecant theta. They are the reciprocals of tangent theta, cosine theta, and sine theta respectively. In the meantime, 3 important Pythagorean identities are shown in red color here. Sine squared theta plus cosine squared theta equals 1. 1 plus tangent squared theta equals secant squared theta. 1 plus cotangent squared theta equals cosecant squared theta. They are quite useful in simplifying and solving circular function problems. The graph on the top is the function curve of sine x. It repeats itself after an interval of 2 pi units. A function which repeats itself regularly is called a periodical function. and the interval between the repetitions is called the period of the function. It is also called the wavelength. As it can be seen, the maximum and minimum values of the sine x are 1 and -1 respectively. The distance between the mean position and the maximum position is called the amplitude. So the graph of y equals sine x has an amplitude of 1. As for cosine x, the graph shown in the middle, it is the graph of sine x translated pi over 2 units in the negative direction of the x-axis. So the period of cosine x is 2 pi and amplitude is 1. The graph shown at below is the tangent x curve. As it can be seen, the lines of x equals negative pi over 2, pi over 2, 3 pi over 2, and 5 pi over 2 are asymptotes. The graph repeats itself every pi units, so the period of tangent function is pi. The range of tangent function is real number, r. Now we are going to evaluate the sine, cosine, and tangent functions at 0, 30, 45, 60, and 90 degrees respectively. For 0 and 90 degrees, as we can imagine in the unit circle, sine 0 degrees equals 0, while sine 90 degrees equals 1. Since the cosine function is the sine function translated 90 degrees in the negative direction of x-axis, so cosine 0 degrees equals 1, while cosine 90 degrees equals 0. Hence, the tangent 0 degrees equals 0, while tangent 90 degrees is not defined. As for the values at 30, 45, and 60 degrees, we use two triangles to evaluate them. The triangle on the left is an equilateral triangle. After drawing the vertical line from the vertex C perpendicular to AB, we have the line CD which bisects the line AB at D. In triangle BCD, sine 30 degrees equals cosine 60 degrees equals A over 2 divided by A, which equals half. In the similar manner, sine 60 degrees equals cosine 30 degrees equals A over 2 divided by A, which equals square root 3 over 2. Accordingly, tangent 30 degrees equals sine 30 degrees divided by cosine 30 degrees, which equals 1 over square root 3, while tangent 60 degrees equals square root 3. The triangle on the right is a right-angled isosceles triangle. Hence, sine 45 degrees equals cosine 45 degrees, that equals 1 over square root 2. Hence, sine 45 degrees equals 1. Based on the above, we calculate all the values of 6 circular functions at 0, 30, 45, 60, and 90 degrees and arrange them into a table as shown here on the screen. To the extension of the values of circular functions in the first quadrant, the diagram presents the coordinates of trigonometry functions at angles extended to all the 4 quadrants. As we have learned, the x-coordinates of all the cross points here are the values of cosine function, while the y-coordinates of all the cross points are the corresponding values of sine function. The tangent function equals the ratio of sine function over cosine function. Based on that, it is not difficult to further calculate their reciprocal functions. Based on this diagram, as we can see, the coordinate axis divides the unit circle into 4 quadrants. The quadrants can be numbered anti-clockwise from the positive direction of the x-axis as shown in the diagram. Relationships based on symmetric properties among functions with angles in different quadrants can be determined. As it can be seen on the screen, the corresponding values in the second, third, and fourth quadrants can be calculated based on the values in the first quadrant through the symmetric properties of circular functions. Now let's discuss and explore the complementary relationships of circular functions through symmetric properties. The top diagram shows the complementary relations in the first quadrant. As it can be seen, when the angle moves from theta to pi over 2 minus theta, the coordinates of the point P change from AB to BA. Hence, sine pi over 2 minus theta equals cosine theta, while cosine pi over 2 minus theta equals sine theta. Tangent pi over 2 minus theta equals 1 over tangent theta. In the second quadrant, as it can be seen in the diagram below, when the angle changes from theta to pi over 2 plus theta, the coordinates change from AB to negative BA. So sine pi over 2 plus theta equals cosine theta. Cosine pi over 2 plus theta equals negative sine theta. Tangent pi over 2 plus theta equals negative 1 over tangent theta. In the similar manner, we can work out the complementary relations in the third and fourth quadrants. In the third quadrant, sine 3 pi over 2 minus theta equals negative cosine theta, while cosine 3 pi over 2 minus theta equals negative sine theta. Tangent 3 pi over 2 minus theta equals 1 over tangent theta. In the fourth quadrant, sine 3 pi over 2 plus theta equals negative cosine theta. Cosine 3 pi over 2 plus theta equals sine theta. Tangent 3 pi over 2 plus theta equals negative 1 over tangent theta. Here we briefly explain the compound angle formula and also show you how we derive it from the cosine rule and the formula of the distance between 2 points. Based on the unit circle shown on the top right of the screen, according to the cosine rule, the distance of the line segment PQ equals square root of the result of OP squared plus OQ squared minus 2 times OP times OQ times cosine alpha minus beta. However, the distance between the 2 points can also be expressed using Pythagorean formula. Since the radius equals 1, the two expressions are equated and both sides of the equation can be squared and simplified. Hence, we find that cosine alpha minus beta equals cosine alpha cosine beta plus sine alpha sine beta. After deriving the formula of cosine alpha minus beta as shown on the screen, we can further derive the rest of compound angle formula of cosine alpha plus beta, sine alpha minus beta, sine alpha plus beta, as well as tangent alpha plus beta and tangent alpha minus beta. Since cosine alpha plus beta can be written to cosine alpha minus negative beta, and then it can be expanded using the derived formula of cosine alpha minus beta. Sine alpha plus beta can be written to cosine pi over 2 minus alpha minus beta, and then it can be expanded using the derived formula of cosine alpha minus beta. Similarly, sine alpha minus beta can also be written to cosine pi over 2 minus alpha plus beta, and then expanded accordingly. As for tangent alpha plus beta, it can be written to sine alpha plus beta over cosine alpha plus beta. After expanding both sine alpha plus beta and cosine alpha plus beta. Every term is divided by cosine alpha, cosine beta. So tangent alpha plus beta equals the sum of tangent alpha and tangent beta over the result of 1 minus tangent alpha tangent beta. In a similar manner, we can also derive tangent alpha minus beta, which equals the result of tangent alpha minus tangent beta over the sum of 1 minus tangent alpha tangent beta. In case alpha is equal to beta, based on the compound angle formula, sine to alpha equals 2 times sine alpha cosine alpha. Cosine to alpha can be written in 3 different forms. It equals cosine squared alpha minus sine squared alpha, or equals 2 times cosine squared alpha minus 1, or equals 1 minus 2 times sine squared alpha. Similarly, tangent to alpha equals 2 tangent alpha over the result of 1 minus tangent squared alpha. Based on the early derived compound angle formula, the following 8 formula can be derived, and they are quite useful in solving circular function problems. The left-hand side of the formula are addition of circular functions, while the formula on the right-hand side are the product of circular functions. In conclusion, we summarize and list the most common and useful formula for you as references. These formula are known as compound angle formula. There are many ways of establishing this formula. Now, we are going to demonstrate quite a number of worked examples to help you understand and improve your skills in solving circular function related problems. Example 1 asks which quadrant the angle alpha falls into, given that sine alpha is less than 0 while tangent alpha is greater than 0. As we know, since sine alpha is less than 0 when the angle alpha is in the third or fourth quadrant, while tangent alpha is greater than 0 when the angle alpha is in the first or third quadrant. Therefore, the angle alpha is in the third quadrant. Based on the given range of angles alpha and beta, example 2 asks the range of alpha minus beta and alpha plus beta. Since beta is greater than 90 degrees but less than alpha, which is less than 135 degrees, negative beta is greater than negative 135 degrees but less than negative 90 degrees. Hence, alpha minus beta, or say alpha plus negative beta, is greater than negative 45 degrees but is less than 45 degrees. Accordingly, alpha plus beta is less than 270 degrees but is greater than 180 degrees. Example 3 gives a sine function and the range of the function is between negative 1 and 9, including both endpoints. The period of the sine function is 6. There are 2 questions follow. The first question is to ask the value of the parameters a, n, and c. The second question is to find the value of y when x equals 1. As for the first question, since the range of the function is between negative 1 and 9, the amplitude a equals 9 minus negative 1 all over 2, which equals 5. The vertical translation c equals 9 plus negative 1 all over 2, which equals 4. Since the period is 6, 2 pi over n equals 4. So n equals pi over 2. After finding the values of a, c, and n, the sine function is y equals 5 times sine pi x over 2, or in parentheses plus 4. So, after substituting x by 1, we calculated the y value, which equals 9.
In example 4, cosine alpha equals square root 2m over 4. The angle alpha falls into the second quadrant, and the angle line passes the point m square root 5. The question is to find the value of sine alpha in terms of m. Since the line passes the point m square root 5, tangent alpha equals square root 5 over m. Hence, sine alpha equals tangent alpha times cosine alpha, which equals square root 10 over 4 after being simplified. Example 5 is to solve the equation cosine 3x over 2 equals half, given that x is between negative pi over 2 and pi over 2, including both endpoints. Based on the given criteria, the general solution formula of cosine function can be applied here. So 3x over 2 equals 2n pi plus or minus arc cosine 1 over 2. After being simplified, x equals 2n pi over 3 plus or minus 2m over 9. So we find that x sub 1 equals negative 2m over 9, while x sub 2 equals 2m over 9. The question in example 6 is to solve a circular equation of square root 3 sine 3x equals cosine 3x, given that x is between negative pi and pi. Both endpoints are inclusive. Based on the given criteria, the equation can be transformed to tangent 3x equals 1 over square root 3. Then the general solution for tangent function is applied here. So we have 3x equals n pi plus pi over 6. After the equation being divided by 3, then x equals n pi over 3 plus pi over 18. According to the given domain, we assign the values n from negative 3 to 2. So we calculate the corresponding x values. Here x sub 1 equals negative 17 pi over 18. X sub 2 equals negative 11 pi over 18, and x sub 3 equals negative 5 pi over 18, x sub 4 equals pi over 18, x sub 5 equals 7 pi over 18, and x sub 6 equals 13 pi over 18.
If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.